welcome you to the interaction on frequently asked question on structured equation modeling part 2. I'm happy to have Professor Jitesh Thakkar, who is the author of the book Structured Equation Modeling, Application for Research and Practice with MS and R, with us for an interaction on structured equation modeling. Professor Jitesh Thakkar is a Dean Academics and Professor in Logistics Supply Chain Management at Gati Shakti Vishwavidyalaya at Central University, Baroda. Dr. Thakkar was a faculty at IIT Kharagpur and has a professional experience of more than 25 years. He is a faculty expert at leading institute of IITs, IM, NITs and other. Dr. Thakkar is listed in the world ranking of 2% scientists by Stanford University. Now, begin with the first question. What is the role of latent variable in structured equation modeling and how are they different from observed variable?
Thank you, Archana. And it's a very interesting question. What is the role of latent variables in structural equation modeling, which is one of the beauty of structural equation modeling, that it accommodates the latent variable and observed variable both simultaneously. So if you just see the observed variable, we may call it as indicators, manifest variables, then these are directly measured variables. Typically, items on a questionnaire or actual quantifiable data, for example, age, income, response to survey questions, and whatever, this becomes observed variable, quantifiable variable, indicators, or manifest variable. If you look at the latent variable, constructs or unobserved variables, then these are theoretical constructs that cannot be directly measured. The name itself suggests it is latent, hidden. They are inferred from their relationship with other observed variables. So if you just see, then some of the latent variables like brand image, you cannot directly capture the brand image. But yes, you are increasing market share, customer loyalty, and other parameters that contributes towards your market, your brand image. Similarly, customer satisfaction is a latent variable, organizational culture. So there are various parameters which you quantify, basically your observed variables, that would define the organizational culture. But organizational culture by nature is a latent variable. You cannot directly measure it. So by modeling these latent variables, structural equation modeling reduces measurement error. So many a times certain phenomena which you cannot capture in your quantitative model leads to error component, but structural equation modeling provides enough scope to establish the relationship between latent and the observable variables, and this becomes a unique value proposition of SEM. If you see the Indian context, maybe let us say you are studying on rural entrepreneurship in India. Let us see what are the observed variable and what are the latent variables. So observed variables could be number of employees, annual turnover, initial investment, responses to questions on risk-taking propensity. All this becomes part of your quantifiable observed variables. If you look at the latent variables, then entrepreneurial spirit, you cannot directly measure, but you can measure it by risk-taking, innovation abilities, proactiveness, and so on. Similarly, access to resources, it is measured by availability of loans, government schemes, infrastructure, and typically SEM would analyze this relationship between latent variables and the observable or manifest variables.
That really clarifies a latent variable, sir. But viewing them as a hidden drives, like a entrepreneur spirits, like access of resources, help us to look beyond such data, which use observed measures like number of employees, turnover rates, loan counts. It's reveal its hidden factors by using this structured equation modeling, feeling almost like a structured detective work, guiding us with the raw numbers of meaningful insights. Now begin with the next question, sir. I am just a beginner in the domain of multivariate statistics analysis. Can you please explain me in the simple term how can I appreciate with the use of structure question modeling, sir?
Absolutely. This is again very interesting question and most practical question. How do I really appreciate or accept SCM as one of the important tool and technique for my investigation, my research? So just see, I can give you a very simple example. Think about a situation. If I run for 1 hour at a speed of 7 kilometers per hour, I may burn hypothetically, obviously it depends on my metabolism and all that, 500 kilocalorie. This can be represented as run burn calorie, and this relationship can easily be represented in the form of a path diagram. Now let us think about another case in which select variables are not directly measurable. They are latent variables, hidden variables. For example, erratic behavior of the student. I am teaching in my class, I see that student feels irritable, not necessarily because of one reason, and I cannot measure directly this erratic behavior of the student in a more direct term, observable term, but it may be because of student might have some problem at home and hence he has an erratic behavior. Student might be sick, some health issues, and that leads to erratic behavior, or student is not comfortable with the teaching pedagogy and hence feels irritable. So there could be multiple reasons behind erratic behavior. So when we hypothesize the relationship between symptoms and cause in terms of path diagram, the necessary data may be collected which may represent a particular relationship, and subsequently we try to investigate that is it possible that this pattern of relationship I have proposed in my model can explain the pattern of relationships. So I have found maybe in my data that if we get a positive answer, then our proposed model are right. If let us say my data, sample data is not fitting well, then I may need to revisit my model, refine it, include or exclude some of the construct. And once again, SCM allows me to investigate the relationship among manifest variables, observable variables, and latent variables.
Professor Thakkar, thank you for excellent example. The running this scenario perfectly demonstrated how to build a path of diagram. Diagram is a when a variable is a straightforward. Then we shift to something which is a less tangible, like a erratic behavior, which you said. It's become very clear why structure question modeling is an invariable for the concept and we can't measure directly. It's drafting the roadmap of cause and effect before diving into the data. To ensuring this, we stay focused on the research goal. Now begin with the last question. What are the key steps involved in conducting the structure equation modeling analysis, sir?
Yes, it is important as we progress in our discussion, our viewers, students, practitioners, data analysts would like to appreciate what are the key steps involved in structural equation modeling. So, if I just narrate in a step-by-step manner, then step one is theory and model specification. So we develop a theoretical model, or we may borrow it from the previous literature. Based on the existing literature, either we borrow or we may develop a theoretical model which clearly defines latent constructs and hypothesize the relationships. Subsequently, as a step two, we go for the path diagram construction. This translates theoretical model into the visual path diagrams. Step three, model identification. I ensure that the model is statistically identified. It means it has enough information to estimate the parameters. Not that I'm trying to estimate some of the parameters like productivity, customer satisfaction, and I have sufficient basis in my model to really estimate this parameter. So that is the third step, model identification. Fourth step, data collection. Gather data from a suitable sample. So certainly you should be cautious. You should not be too much biased, but random sample even should be selected cautiously considering the demography, considering the income level, whatever may be the issue you are addressing, and ensure the sufficient sample size. On sample size, in my book, I have provided very clear-cut guidelines, how many variables, parameters you are including, and what is the nature of these variables, and proportionately, what number of, say, data you should collect or what should be your sample size. Step 5, data preparation. So you clean, screen, and prepare the data. Check for any missing values, outliers, normality. Step 6, parameter estimation. You use your SEM package, software, MOSR, whatever, to estimate the model's parameters, that is path coefficients and factor loading. Two most important terms. Path coefficient, suppose I have conceived a path between two variables, let us say student attention in the class and the performance in the exam. Then you determine the path coefficient to justify how significant this relationship is. Then you see the factor loading. How much is the factor loading on a particular path? That will help you to appreciate what is the importance of a particular factor. Model fit evaluation. Assess how well the model fits the observed data using various fit indices. So there are many fit indices like GIF, chi-square, many fit indices are there. You can use the fit indices, relative fit indices, absolute fit indices. Subsequently, step 8 is model respecification only if necessary. So as I mentioned, if I am not able to estimate the parameter and my observations are absolutely different than what my model speaks, there is a case for model respecification. My model exhibits a poor fit and make theoretical justification modifications to incorporate the necessary changes in the basic model and then re-estimate. So this may be iterative till you really reach to the stage where your model fit is adequately established, verified, well within the fit indices, and then you can only proceed further. And that is the final step, that is interpretation and reporting. So if you see the Indian context, a researcher studying the adoption of e-governance services in India would first develop a theoretical model, collect the data from the citizens, prepare the data, use SEM software to estimate the relationship between construct like perceived usefulness, trust, behavioral intention to use, and so on. And they would subsequently, iteratively refine the model based on fit indices.
Professor Thakkar, I appreciate the step-by-step you break down the how the outline have practically workforce. From specifically the theoretical model, from the data validations, parametric estimation, to model to reframed based on the fit indices. That erratically the cycle ensuring the rigorous at every stage. Applying this e-governance research show how anyone can follow these steps, process reliable and actionable results. I conclude this. Professor Thakkar, thank you so much once again for walking us through structure equation modeling in such an approachable way by moving those hidden variables into running full analysis, felt like by piecing into together a puzzles, each steps building on the last. I'm excited to put this matter to work and I'm looking forward to explore more with you in the next session, sir.
Thank you very much, Archana. And today we explored some of the important questions which has helped us to advance in our journey in our series on frequently asked question on structural equation modeling. We completed part 2 and we will continue with part 3 to throw more light on some of the important dimensions of structural equation modeling and generally arising queries, frequently asked questions by the researchers, data analysts, and students. Thank you.